in this density lab, we will measure the density of the 3 cylinders, a rectangular solid, a copper wire using the micrometer, these using the Vernier caliper, and an irregular solid. This is irregular because even though it's regular, there's a hole in it which makes it irregular. For this, we will use the overflow can and the graduated cylinder. And for the cylinders, we will use the Vernier caliper. I will take a measurement and bring the caliper close to the camera. You will read off the data. And we will do the same for the wire. So let's start off with the cylinders. First I will show how one of them is done. And then we'll pause the video so that it doesn't take too much of your time and show you the values. Each measurement will be taken 4 times. We start with the introduction to the Vernier caliper. So this is the Vernier caliper. This is the main scale in centimeters, main scale in inches, which we will ignore. This is the Vernier scale down here. These are the jaws of the caliper, and the way it's used, we take an object. Let's take a cylinder. First we move it in. We always need to move it using the screw, and we take a measurement of the zero error, if any. So we read it from here to see the zero error. Then we can bring it in here, squeeze it in, okay, bring it right under the center, and then we read off the value from the scale. Now this distance is used to measure the outer diameter, but if we want to measure the outer diameter from here, but if you want to measure the inner diameter, we use this and open it up, and then that gives us the inner diameter. And then if you want to measure the depth, how deep it is, then we have on the back side this thing sticking out, so we push it in and push it all the way down from here. Okay, it's not going anymore, and this distance, which is read here, is the depth of the cap, which is the same as the outer distance here, the inner distance here, and the depth here. They're all the same, and we read them off from here. So now the manual has a description of how to read this. So now let's start off. First we will get the zero error, then we'll get the length of cylinder number 1 like this. I bring it close, then we'll bring it the diameter of cylinder number 1, and I'll bring it close, and then we put that away. We pick up cylinder number 2, and then we measure its diameter and length. Don't have to be in the same order. So first we'll take the diameter and length of all 3 cylinders and this rectangular solid, and then we'll repeat this process 4 times. Each time before we repeat the process, we will take the zero error. So first let's start off with the cylinders. Let's call this cylinder number 1, let's call this cylinder number 2, and cylinder number 3, and the rectangular solid. And you need to remember 1, 2, and 3, and the rectangular solid. Don't mix up the data from these. Now this is round 1, zero error. You can pause the video as we go along, and then you can do the measurements. So zero error, round 1. Cylinder 1, length. Cylinder 1, diameter. Cylinder number 2, length. Cylinder number 2, diameter. Cylinder number 3, length. Cylinder number 3, diameter. Rectangular solid, length. Rectangular solid, width. Rectangular solid, height. Second round of data, 0 error. Length cylinder 1, diameter cylinder 1, diameter cylinder 2, length cylinder 2, length cylinder 3. Diameter cylinder 3, length regular solid, width regular solid, height regular solid. We now start round 3, 0 error. Diameter cylinder 1, length cylinder 1, length cylinder 2, length cylinder 2, diameter cylinder 2, diameter cylinder 3, length cylinder 3. Length regular solid, width regular solid, height regular solid. Measurements round 4, fourth set of measurements, 0 error.
Take it.
Okay, so 4 measurements have been done with this. Now let's go on to the overflow can and get the value for the irregular solid. We now measure the masses, and this is the first set of data. So first we tear it. In the first cylinder. Second cylinder. Third cylinder. All the values are in grams. Second set of data. third set. Fourth set of data. This is the overflow can, the graduated cylinder, and the irregular solid. We will fill the water beyond the overflow, let the water drip out. It's going to take a little time. When the water stops dripping, then we will dip the irregular solid in it, and then the water that overflows will be equal to the volume of this solid. So we'll wait a little while till the drops stop coming. Now we'll take the initial level, and this will be the level of water before immersion of the solid, and I will bring the camera close to so that it can be seen read off, and we may have to stop, pause, cut out portions of the video if it's taking too long. Now that's the initial level. Now I'll dip the irregular solid, collect the water, and this will now be well, once it stops dripping, that will be the new level. The difference of these two will be the volume of the solid. It takes a little while to completely stop dripping. Okay, so now we can read this level, and that will be the final level, and the difference of the two is the volume of the irregular solid. Now we'll do the experiment. Dry this off so that it doesn't take some water with it. Initial level, final level. Let's remove some water. Put it back in again. That's 20. So this one is 10. 10, 20, 30. So this is the initial level. This is 50, 30. That's the final level for the second measurement. Surface tension. Okay, initial level. Final level. Now do this once again. Initial level. Final level. Do it one more time. Initial level. Final level. We first tare it. It's set on grams. Put the irregular solid on it. Tare. Again. Tare. Again. Pretty consistent. Okay.